Okay, for people who are joining this fairly rare Sunday live stream, we are talking about computational chemistry and things being prepared for the soon to be finished next version of Wolfram Language. Okay, let's go open the relevant guide page. So you said it's called molecules?
Just molecule. I could change
it's
that.
not the best name.
Right, I'm new to making these.
All right. Is that it? Those are all the functions we have?
No.
So where's the list of ones we have?
So that must mean my recent documentation push to CDS did not go through because I pressed update instead of commit. And
okay, so can you commit it right now?
Absolutely, going to commit right now.
Okay. So let's just check that things are working here. So if I say molecule, how do I get if I say random entity chemical, by the way, has somebody reported that stupid bug that's still there, that this thing is cut off? Is Tishma with us? Who is
I can report it.
I heard. Who is, let's see, who is here? Lots of people listed. I don't know who's actually here. Well, okay. Okay, so let me know when you're ready for me to do this update. So each one of these, if I say for these, molecule plot 3D, right?
No, right, so you would need to create molecules from them. So you would map molecules.
Okay, so that shouldn't be necessary, right?
Okay, so right, so which all function should take? So molecule takes certain items and will construct from it.
Sorry, I have a. Remember, we had this big ontological discussion where we decided molecules are different from chemicals, are not entities.
So hold, you can update.
Yeah, but obviously, right. But okay, hold on.
I could see the argument that molecule plot and molecule plot.
Yeah, 3D. It's just a piece of essentially user courtesy, I think. Because otherwise, all that's going to happen here is, what do? I say molecule, map molecule onto %1, and hopefully I will get, why is it so slow? Okay, I'll get that. And now I say molecule plot 3D, and that also didn't work, which is also wrong.
So how would I'm not entirely certain how we would combine those, if we would just make a row out of them, or so
no,
if you
just make a list. It's just a listable function. That's it.
Okay.
So that's what I think we should do. I mean, unless there's some reason why we think that that's a bad idea because of something in the future with multiple molecules.
I would be hesitant also here to make this immediately listable.
Because I mean, you could imagine that somebody would just want to see the two them combined in a grid of some kind.
I guess.
Or if you do molecule plot 3D of a list of two molecules, you might want to have them together in the same frame.
Positioned how?
Right. So it's not entirely obvious how to do that.
Yeah, they should be joined first into a single frame before they would be shown together and possibly overlapping. Basically making a new molecule that has two separate pieces of stuff in them.
Right. Okay, but let's go back to the question of whether molecule plot 3D should just work on
chemical entities.
Yes.
And so if the chemical entity itself has atom coordinate or the atom positions, the 3D coordinates in our knowledge base, then
which don't. I thought all of them did.
No, there's a fair number that don't. Salts or just ones that when we get them from our source, they didn't have it, and various metal complexes.
What would a salt do?
Let's see.
So like we're talking sodium chloride or something.
Right. So in this case, if those entities don't have 3D coordinates, Molecule is going to try and create them. And Molecule will do that. It'll embed this disconnected components and then just place them in the same way that Graph will lay out disconnected components.
Okay. Does that make sense?
I think so.
Okay, so this is something where it says unable to generate. So when it says generating 3D coordinates, is it computing them or are they pre-computed here?
So in that case, it's computing them.
Why don't we store the pre-computed ones, at least for the molecules that we know are in the knowledge base?
Right. I have gone through on a couple of occasions and tried to update and pre-compute them for ones in the knowledge base, and there were some that just did fail.
Okay, so what the heck happened here?
Right. So that's got disconnected.
It's got hafnium in it.
Right. And so the hafnium is just that lone sphere. And so, right. So the embedding routine that I have right now will embed the different components separately and then combine them, just laying them out.
Okay, but in this particular case, so what does this mean here? So in this case, what does this mean? There's a random piece of hafnium there.
Right. So in reality, that the bonds in that complex are probably, let's see, I would imagine that you've got the two planes that are parallel to each other, and the hafnium is in there somewhere in between, and you have the ions hanging out around the hafnium. But the bonding of that metal complex is a little bit more complicated than can be just described using single and double bonds. And so our sources didn't provide us with any bonds from hafnium to the cyclic compounds there, and so we don't have any bonds going to hafnium.
Okay, but so hold on. There are multiple issues here. Okay, so let's start off with the most. So I had not realized. I think we had talked about it before that there are molecules that have this kind of brokenness in them, or even this kind of brokenness where it can't do anything. What happened when it couldn't do anything? I mean, why isn't this just a bunch of disconnected atoms in the case where it can do practically nothing?
Well, it is handling that okay up to the connected components, but it doesn't know how to connect them together based on charge interactions and things like that.
But that's because you can only do certain kinds of well-known atom types. Is that correct?
That's part of it, and the organic parts can certainly put together, like the one on the right, the magnesium bromide compound. It handled the organic part just fine, but the magnesium and the bromine should be associated to each other, not too far away because of the ionic attraction between the two, and the benzene ring should probably also be coordinated with the magnesium, or possibly the oxygen and the ether would be. But the rules for inorganic chemistry are much different than those for organic chemistry, and the library we're using does not have anything to handle the inorganic part. So this is...
Does it exist? Is it part of the state of the art or not?
I'm not that familiar with it myself. There are some force fields, as it were, for inorganics. I don't know how extensive they are or how much they're used, but I have seen...
There's a chap who was at our technology conference last year who is a force field aficionado who wanted to get us to use some force fields. I think he worked for one of the national labs. Maybe Danielle could check into that. I mean,
yeah, I don't remember who that was. I only met the one chemist from University of Virginia, I think it was.
Okay, well, so there are a few of these. So there's that. There's also this chap at Harvard who we did a bunch of stuff with a number of years ago, and it might be worth looking. I mean, I think ultimately what he had hoped to be able to do of some kind of ab initio computation of molecular structures didn't work out, at least at that time. But it would be nice to recontact these people and see if this is now doable.
He's not at Harvard anymore. He moved to Canada.
Oh, okay. Well, whatever. The
Right, but even there with the stuff that he was doing, it focuses more on connected molecules rather than metal complexes and things that you need more of the crystal structure in order to describe how they're laid out.
Right. Well, so okay. So okay. So this is my chemistry learning moment here. But let's just do sodium chloride here. Let me just understand.
So you're saying if we have disconnected, we fail? You give a message there, at least?
No, so we don't have a way of doing an educated layout.
Whoa, what happened here?
Okay, so that seems like that's definitely a bug. I will fix that.
Okay, but so if I say molecule of atom, sodium, atom, chlorine, right?
Right.
What will that do? What the heck is that doing? It's got some random weird hydrogens hanging out there.
Well, because we didn't put charges on them.
Yeah.
Okay, what do I do to put charges on?
Put the string in the sodium atom. Do string formal charge goes to 1.
Why can't I do Na+? Why wouldn't we allow that?
That would be more like smiles. It could be done that way as well.
It could be done. I mean, so I could make it. I could make atom Na+ evaluate to Na formal charge goes to 1.
Yeah, I think that would be a good thing. Okay, so there. Okay, so that's what it does for sodium chloride.
And so then
why does it say formula ClNa? Why doesn't it do the usual way around?
No,
right,
that is correct. The inorganic parts are alphabetic.
So we do the Hill formula where you list all carbons, all hydrogens, then everything else in alphabetical order. Just because we would need a heuristic for saying which.
Yes. Why not?
No, I agree. It would be good to do. I just haven't.
Let's find out the heuristic. Should be easy to figure out. Just look at for all of our, like for example, if we have sodium chloride here.
But Stephen, that's not obvious that is right, because this one is not yet a bonded object.
Okay, but so when we have a thing that says formula here, right? We are using the usual conventions about ordering, right?
No, that NaCl is the colloquial way you would expect to see it. That's what. So if you have
I understand that, but
well, no. So in this case, actually, I could be doing a better job because generally with salts we put the cation first and then the anion. So I could be doing.
Okay, but so there's 2 points here. One is to have a string Na+ here instead of having to write the formal charge thing out explicitly. Seems sensible, doesn't it?
Let's see. Am I muted?
No, you're not muted.
Sorry. Yes, it does seem sensible. Sorry.
Okay. All right. So let's roll back here for a second to the original question of whether molecule plot should be able to take a chemical entity and should automatically.
If we think this to the end, then we want, I think, region of a polyhedron entity, graphic 3D of a polyhedron entity, and many, many more things. I'm not saying that's the wrong thing, but currently we do.
I think it's the right thing. I think that's the courteous thing to do for users. But okay, this is probably not the time to figure that out. But I would recommend doing this. Actually, Sandra in our live stream points out that plotting functions do not generally show listability, and I guess I'm caving on that particular issue. I agree that this can require mapping over the molecules. Okay, so let's roll back these issues. So first point is making molecule plot automatically go into chemical entities. I think that should work. The second point is what to do about these non-correctly rendered chemical chemical forms, and I think there should be a message generated.
Okay, so a message saying this is a disconnected this molecule has disconnected components. We are the relationship.
Well, let me just understand what the issue is. So
if it comes from an entity where we know it, otherwise we might not know. Like for the NaCl example, we currently don't know about the bonding.
No, right, but if we don't know, I think we shouldn't we say something about how if you do a molecule plot, you're clearly not getting a correct molecule plot. I mean, if I do a molecule plot from this, I'm just going to get two random spheres, I would assume.
I think that's actually, because this example comes up, I looked into it. It's basically just in the last years we get an idea how this looks like.
What do you mean by that? I mean, it's a crystal, right? I mean,
no, it's a molecule. In vacuum NaCl molecule is just understood the last few years. It's not a crystal, it's a molecule.
Oh, well, does anybody care about that? Okay, so first point is there's a bug here. Whatever the symbol called with zero arguments is clearly wrong.
Right, I'm taking note of that.
Okay, but so, Michael, you're talking about a free-floating single NaCl molecule. Does anybody care about that?
But this is what you had in great detail discussed in your blog about the ontology of chemistry, that we speak about single molecules.
Yeah, I understand.
Not about bulk objects.
I understand that point. I'm just asking, does anybody care about the single molecule NaCl?
I think, yes, people are really interested how they behave because they're really interesting objects.
Well, but that's a different thing from them being the objects that one actually, looks at in sort of real life chemistry. So in any case, we clearly know that something went wrong. We're not showing a bonded molecule here. We're showing something else, right?
Right. And so actually the library that I use for generating coordinates for embedding the molecules will just won't even try to do disconnected components. If you give it something with disconnected components, they all get embedded separately, and they have their origins.
Okay, but I don't understand. There's a question. Okay, there are bonds, and the bonds are made using some kind of valence rules. Yes.
Yes.
Okay, so you know perfectly well when you failed to make those bonds, correct?
Well, so in this case, there aren't bonds to fail to make. There is no bond between.
I understand. I understand. But with the hafnium thing, there is some kind of weird, chemical structure, but you can't make it, right? Whereas in something like this, you've got a single connected component made from organic, chemical components, right?
Right, and there are explicit bonds that connect all the atoms. In the other cases here, there are no explicit bonds because it's electrostatic charges holding them near each other, either in solution or in a crystal structure. But there are no single, double, triple type bonds.
No, I understand. Okay, so I mean, these are ionic. Presumably, there's some kind of ionic bonding in quots rather than some kind of.
And we would need to develop a heuristic to make a guess, an educated guess at what the coordination chemistry is for the metal, and then coordinate the ligands around it appropriately.
Okay, so what you're saying is there is, okay, so in a sense, what we're saying is these are, covalently bonded things, right? There are other things which have ionic bonding, which aren't the subject of useful molecule plots. Is that a true statement?
No, they are a subject of useful molecule plots. We just don't have the capability right now to give them good 3D coordinates because we don't have stuff that handles the coordination chemistry.
Right. We don't embed separate components together intelligently. I lay them out so that visually they don't overlap. And I actually would be fine with issuing a message saying that.
Yeah, well, I agree. That's what I think we should do because, I mean, so in other words, okay, so there's two branches to this issue. One is, it would be nice to see if we can find, some ability to actually compute these. I mean, at a very naive level, is this not determined by just electrostatics? by the minimum
Yeah.
energy configuration of electrostatic system.
Yes, and the electronic state of the metal atom as well for the coordination. If it's got 4 ligands, it could be square planar or it could be tetrahedral, depending on the orbitals and how they're occupied.
But so is that already known from, or is
a lot of it's known? I'm no expert in organic chemistry. A lot of that is known.
But I mean, is it known, given that there's a random hafnium atom hanging out here, it's not known what the electronic state of that random hafnium atom is for this?
No, I'm pretty sure it would be known.
How would it be determined?
Knowing what the charges are of all the components would tell us what the charge is on the metal so that it's neutral. We're assuming that it's overall neutral.
I see.
And then knowing the charge state, there's probably only 1 or 2 electronic states that would be allowed, and probably a heuristic that could choose between them.
Right. All right. So we
should find something like that to handle these.
Yes. Okay. Fine. Okay. So why don't we say something like, you tell me what this should say, something about ionic tell me what this should say. I don't know nothing about chemistry, so I mean something like
right, so non-covalently bonded components. So the molecule contains multiple covalently bonded components.
Well, it might not. It might contain none. It might be like NaCl. Non-covalent bonding detected or something, encountered, required, involved. This molecule involves non-covalent bonding.
So I feel like we should just focus on the fact that they're disconnected structures, and that would cover salts, charges, or metal complexes. Just the fact that.
Well, but disconnected with respect to covalent bonding.
Right.
So that's what we have to say, because that's what the connection means.
Or we could just say non-covalently bound fragments detected, or something like that.
Okay, bonded, non-covalently bonded fragments encountered.
Probably bound instead of bonded.
That just seems like a really weird word. Non-covalently bound fragments.
Fragments, yeah.
Encountered, displaying as disconnected components.
Yeah, that seems reasonable.
Okay.
But it's not the issue of display. It's an issue of representation. It's in the underlying object, not in the graphics.
Okay.
Right. So the atom, the coordinates
being treated, non-covalently bound fragments encountered,
and treated as disconnected components.
Being treated. Something like that. Is that right?
I think so.
Yeah, that seems right on.
Yep.
Okay. All right. So at least that will give people some idea that their actual molecule doesn't look like this. I can remove the word R here. Okay. All right. Fine. Let's go back to what we were. We have a long comment here on our live stream. Just a minute. Typically. Yes, look, I agree. Michael Hale on our live stream is reinforcing the incorrectness of my claim that we should have molecule plot be automatically listable. Yes. Okay. All right. So in this case, so I don't understand why this isn't generating the same message that this generated, unable to generate 3D coordinates. See, I mean, you're being able to generate well, maybe we should say encountered non-covalently bonded fragments that are being treated, that are being treated. Oh, whatever, are being treated. That's fine. Okay. But don't you think it should separately produce a message saying the 3D structure is wrong? The rendered 3D structure is wrong?
So isn't that the point of the covalently?
All right. Okay. Fine. All right. We can leave it at that. Okay. All right. Let's go back to our guide page here.
Okay, that's more like it.
Okay, so let's look at where this goes from the root guide page.
Right, and so the layout of the guide page I know nothing about, and it should be changed. I just wanted to get all the symbols.
Okay, I understand that. So let's go to the root guide page here. So on the root guide page, we want to go down wherever it is. Wow, where the heck is it? What, did I miss it? Oh, here we go. Okay. Well, so we have a major new area. Why has this been, why do we not have this? Crystallographic. Michael, why is that not a thing?
Yeah, there were issues with it. Thinking whatever.
Okay, and what happens? What's the relationship between what we've got here and the chemical reaction data? And whatever this is.
That is a good question. I don't know. The whole reason I started on this was so that I could improve chemical reaction data so that we can talk more intelligently about the reaction. So chemical reaction data needs a lot of updating.
Okay. But in the case of the crystallography stuff, we do have, I mean, okay, so this is kind of a mess here because we've got multiple things going on. So we do have things like lattice data, which for some reason is not mentioned here. Right, so right now, what's the relationship between this? I mean, the whole question of how the thing forms a crystal is a whole different issue. Although I have to say, I would think that lattice data should find its way onto that page about materials. And we should also really understand why what happened to this? What happened to this? This looks like it's got all kinds of grand stuff in it. Although I think in modern times, this is probably not the way we want to do it. We want to do it through entity property. And by the way, that reminds me that these pages need to be, all these pages that have blah, blah, blah data on them need to be redone in terms of documentation now that we have entity pages. That makes sense? Since we're trying to de-document these kinds of functions.
Yeah.
So, gosh, we don't have anybody from project management here, I suppose. So can we?
I can communicate.
Yeah, can you communicate that? Yeah. I mean, that's a project for Brian and Alan, I think.
Yeah, I know.
Gosh, that's kind of a complicated thing because I mean, this page, for example. Okay, so. So this page, so we're going to need to add a whole lot of stuff to this page, basically. I mean, somehow this has got to have. Humph. Well, there's going to be a section on chemical computation here. Well, it's probably molecular structure and chemical computation. Or is it primarily molecular structure at this point?
I'm not even sure what exactly chemical computation would entail.
So to me, that means looking at reactions and
All right,
such,
okay.
which is where we want to go.
It also should include all the stuff we do with modify molecule and energetics in terms of force field optimization and hopefully one day electronic structure optimization.
Okay, but do you believe that molecular structure is the right category here?
I would say yes.
Yeah.
Okay, so then we've got molecule.
Why not chemical structure?
Because
But then we are back to the bike.
Chemicals come in bottles.
I see. Okay, never mind.
symbolic representation of molecules and their structure. Is that a fair way to say it?
Yeah.
Okay, so now what we've got under this is, I don't think we need to list it here. We've got atom, we've got bond, right?
Right.
What else do we have here of that type?
Well, so that's it. I mean, those are the two types that it takes.
Yeah, everything else is handled through options.
Okay. Well, then we've got things like include hydrogens, which I think are it's just worth giving some indication that there are things like that on this page.
Well, then definitely stereochemistry elements would be next.
After bond.
Right, it's more important structurally than include hydrogens.
Okay, so now we've got so this is well, wait a minute. So this, we've got to indicate that it automatically computes. By the way, we need to add some stuff up here when it's we got to indicate that this automatically computes atom positions. Well, render molecules with automatically computed structure or something. Is that a fair statement?
Yes.
Or geometry.
Yep.
Structure or geometry?
So structure would apply to both 2D and 3D, but if geometry, we usually restrict to talking about 3D.
All right, okay. So then we've got other kinds of things here. I mean, this, we're going to have a real page about this. I'm just trying to fill in this approximate page. What's molecule? Okay, so molecule value. How much stuff is supported in molecule value?
There are quite a few properties.
Fair amount.
Let's see.
Yeah, we got dozens of properties.
They look fairly ugly at the moment. I'm working with Bob to come up with better names for a lot of those, and we have them. I just haven't updated the page.
Okay, so should that be given before? Okay, so then molecule value.
Molecule value, and then probably modify molecule.
Well, okay, hold on a second.
So you would say it's for retrieving computed properties of the molecule, or something like that.
Values of computed properties of molecules.
Yeah.
Okay, so now let's find molecule substructure.
Right. So that's helps you find a pattern inside a molecule, and it gives a mapping between the molecule and the pattern.
Okay, so on this page, I don't think we're going to give all those pieces. I mean, What else deserves to be? I think here. Let's see. You have the. Where's the modify piece here? Where's the thing?
It is missing from the guide page. Sorry.
Okay, so what's it called? Molecule modify?
It is, yeah.
So we're still calling it fine molecular substructure, right?
Molecule substructure.
Molecule substructure.
It's very similar to fine graph isomorphism.
So let's say molecule pattern, and then let's say molecule modify. And then ... there. Okay, so now let's go to the main page here. Let's see, what do we want to call it? Molecular structure computation or molecular structure?
Molecular structure and computation?
Yeah.
Okay. Okay. So let's start off here. Yeah, again, this page is going to need changes. This, by the way, won't render correctly. That left-hand side needs to be tweaked. Okay, this page needs to be renamed. Do you know how to rename? Oh yeah, it has a rename mechanism. I didn't know it had a rename mechanism. That's very cool. I didn't know we did that for guide pages. Okay. Remarkable. So high tech. Okay. All right, so let's go ahead here. That needs to link up to that. And by the way, this needs to link to why doesn't that? This is so stupid the way that happens. Molecular structure and computation. There we go. Okay. Meanwhile, we need to make sure that the graph theory page is linked to this, and so on. That piece of knitting will need to be done. I have to say that I'm not sure that this shouldn't be a top-level page. From the root guide page, because it seems to me, I think it should be a top-level page here.
I wouldn't argue with that.
Why is social sciences? Why did that not? I mean, see, we should add a bunch of pages now that we are able to link directly to entity description pages. We should do that. Okay, so here, what order should this be in? Physics and chemistry. Arguably, do you think it should go right here?
Right, that sounds, I mean, yeah, so right there with chemistry.
No, after that. Do you understand? I mean, so it's got to go on, it's, okay, whatever. I forget how to make one of these. We make them so rarely. Okay, let's go here, there. Sorry, let's see. What? That's crazy. Is that a bug in the edit? Oh, look at that horrifying bug. See that bug? All right, I don't know whether that really belongs in that position. You know what? I'm going to put it in its own separate subsection here. I mean, it's our first example of something that is okay, let's go back over here. All right, so is this, how complete is this list? It's missing molecule modify?
Right, I think that is everything. And there's one on there that you've rejected in the past, and I wanted to ask one more time about.
Which is what?
Register molecule property.
No, it's not going to happen.
Okay.
I don't know what it is, but it's not going to happen. Not now.
Right. Okay. It's so after the last.
It's just awful.
Okay. Okay. So after the last, when it came up the last time in a Twitch, a user had chatted saying they specifically that is the kind of thing they would want, but it's an internal function, and if they find it, they can use it.
I don't even understand what it's supposed to do. You're trying to.
So the molecule value interface, like using molecule value and subvalues to retrieve computed information on a molecule, is powerful, and
I am well aware of that, but this is not the way that this idea of assigning values like this. You know, how globally does it assign the value? Did you understand what I'm asking? And I don't understand why you're saying register. It doesn't make any difference. I mean, if you're going to, okay, what is it supposed to be doing? It's supposed to be allowing you to say molecule value of blah 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 equals. Is that correct?
So you could say create your own property. Call it the carbon bond.
I know, but yes, okay.
And so you register that
right. So we've got a whole mechanism for doing this with annotations for graphs and so on, and it's not this mechanism.
Okay. Okay.
Okay. So let's not put this in.
Yeah, I'll take it out.
Okay, let's go back to the stuff that we can do here. And by the way, we need to understand how that annotation mechanism can be applied to molecules. Make sense? I mean, there's this whole, yeah. I mean, this is a completely different mechanism than we have for any other type of thing, right?
No, so
not really.
So to me, it's
like entity value.
Yes, to me it seems like a when you're making an entity store, your own entity store, you register a function as a property, and then whenever.
But you don't. That's not how it works. When you make an entity store, you create the whole entity store, and if there's a computed property, you give it as part of the entity store. You don't retrofit it afterwards, right?
Right.
Okay, so this is a different mechanism. In the case of an entity store, is there a way of doing that as an L value? Entity value equals? I don't think so. Michael?
Sorry, my Zoom just crashed. I didn't hear the question.
The question is, in the case of an entity store,
you
can't use entity value as an L value, can you?
For individual ones, but not for introducing whole new ones.
Right. But it only, when you do that, it is only local to that session, correct?
This depends if you save out the entity store.
Well, fine.
If you don't touch the entity, obviously it cannot be preserved anywhere.
Yeah, okay. Okay.
But if you save it, then it's in the entity store.
But entity value equals will modify that entity store, correct?
Yes.
But only in memory.
Yeah, exactly.
Fine.
But still, like,
so.
there isn't right now a mechanism to add a new property. You can add new values to properties that you have defined in the entity store.
Sorry, say that again.
If you have defined a certain property in the entity store, then you can add later on with L value a new value for a certain.
Yes.
But you cannot add a whole new property this way.
Right.
Where JSON wants to add a whole new property, not a value of a property.
Yeah. Okay.
Right. So I'll take it
not
out.
doing it yet.
Yeah.
Okay. Other fishes to fry first. Okay. So let's start off over here. So do you have a function page for molecule?
Yes.
I wish the format was correct here. Right, that's the wrong formatting. You know that.
Okay. I
mean,
so
I don't know how you made it, but I know. So
Okay.
please find out how to do it, so that, because otherwise somebody else has to come fix it.
Okay. Yeah.
Okay. So you want me to retype this? I mean, because this is what's going to have to happen here. So you do atom. I mean, this is the way you enter these, right? You know that, yes or no? Did you know that?
Sorry, I was muted. Yeah, that is what I was.
Well, for some reason you didn't get the thing to work right. Oh wow, something is wrong with the structure you have here now. Oh gosh. Okay, I'm going to enter this one, but then after this, please do these yourself and make sure it's right. And who is supposed to be checking this stuff? What is the pipeline, Michael? What are we doing here? How is this being done?
I thought Jason writes it and then Bob looks through as the
okay. But who knows how to? Who knows the way that documentation is supposed to work? Who in this pipeline knows that?
I thought actually Jason by now would know it.
Okay, so it's wrong here. Okay, so please get this right. Did you understand what's wrong here, Jason?
So
that
the
font is wrong, but worse than the font being wrong, it means the tagging is all wrong inside. Okay.
Right. So I will pay more attention. I will look at other documentation tools and see
but you need to get somebody like Brian or somebody to help you go through this, right?
Jeff knows this very well.
Okay, fine. Yeah. So he's the right person to do it then. With atoms, atom ion, bonds, bond I. Okay. No, it doesn't create. It represents a molecule.
This is very questionable.
So in this case,
no, I would say
it doesn't create anything. No, because create means that it's a structure that we're going to be able to. It's a persistent structure, which it is not.
So could it return in this case? Because
it doesn't. It's not unevaluated. It evaluates non-trivial.
I understand. Okay, so let's say it gives a molecule based on. Gives the molecule corresponding to the specified chemical name or spiral string. Is that correct?
Yes.
This just frustrates me so much. I don't know how. I have no idea how you even created that structure.
I imagine that I typed it as a string and did the
which is wrong, right? Which is obviously wrong, right? So you need to use the actual tools which do the correct tagging, right? You know how to do those, yes? All this stuff with template input and so on.
Yes. So molecule is probably one of the ones that I made first and have gotten more practice since then, so I will start it anew.
Right. Someone is commenting about multi-frame mol/mol2/PDB files. I assume multi-frame means it has more than one molecule in it. Is that true?
Yes.
By the way, this needs to have on this page for sure. We need to be talking about import, and we need to be talking about formats like mol, right?
Right. So out of the box, we're going to support 3 formats for importing a molecule: mol2, SDF, and mol. And of those, 2 of them have multi-frame support. So you could say import this SD file, give me only the 10,000th through 12,000th molecules, and it works, and it does it quickly.
SD, what are those things called? SDF?
Yes.
Is that what we call it? Do we call it mol with lowercase ol or with all uppercase?
I believe they're all uppercase.
That's what I thought. Okay. Okay.
And we're interested in adding PDB support, but that's going to take a little bit of work.
I thought we had some PDB mechanism already.
Oh, we can import beautiful graphics from PDB, but to create a molecule from them, they usually don't have all of the bond information that you need. But it can be inferred, but it'll take a little bit of work.
I see. Okay.
But they really are beautiful graphics.
I know, yeah.
Jason, I have some stuff to send you about PDB and importing that came out of the summer school.
Excellent.
Oops, what did I just do here? Great. So that would be something has gone wrong with that format as well. Gives a molecule corresponding to a chemical entity. No, why is it? No, don't do that, please. Right? If it's a name.
No, you're absolutely right. This was the first one I wrote, and I haven't
fine.
rewritten it.
Not a problem. Okay.
Unfinished
and that presence
there, obviously.
Yeah, what does it mean?
Inferred from the valence of the heavy atoms.
But what about the include hydrogens thing?
Right. So that is an option listed down below.
Yeah, I know, but how does that affect the statement?
Right.
Let's say include hydrogens is false.
So right now I have, let's see, 3 settings for include hydrogen that can be all explicit, all implicit, or none.
Okay, so this statement here applies to which of those cases?
All explicit. With the default setting, include hydrogens goes to all explicit.
No.
Right. No. Hold on.
No. Look, I really think you should go over these pages.
We know they're not perfect. Jason and I just talked about this an hour ago.
Okay. Okay. Okay, obviously you've got to make those correct, right?
Yes.
So an atom index. So somewhere you probably got to say what that is. Only the atoms with indices ID sub I listed, included.
Copy is probably the incorrect word.
Right. We could just say gives a molecule, or
gives a version, gives
a molecule, because there's really no relation between the two.
So it gives a molecule with
containing only atoms with indices ID sub I from mol, together with all appropriate bonds. Something like that, is that right?
Yes.
By the way, could you report the incredibly silly bug that I'm getting a horizontal cursor here? I don't know if you can see that through the whole Zoom session and so on. Can you see the cursor?
Yes, I got it with a screenshot there.
Okay.
Do the hydrogens come along also, Jason, with us?
Let's see. For what?
If there are hydrogens attached to, ID1, ID2, do they come along also?
So that so you have different behaviors there. You can so if you said include hydrogens goes to none, then what you get back has all hairs where they would have been.
Okay, so it's handled by the options as we spoke earlier this week,
right?
Last week. Okay.
So I don't understand why some of this documentation is in molecule rather than in atom. Seems wrong to me.
Right. So okay. So what all should go in molecule? Like should molecule
stuff that says what is in the molecule. But I mean, having all these things, you can set tons of things for an atom, can't you?
Well, so you can only set those intrinsic properties, and then everything else is computed properties.
Okay.
But you're right. That table could definitely go to the atom page. The table above it should stay on this page because it's about
yes, I
molecule
understand. And don't say C because that's a specific thing, right? So you could say SY with symbol SY, EG, C. What's a two-letter one that we can actually deal with? An A?
Or CL.
Okay.
So I like this because originally I did have lowercase sim in quotation marks, and it looked wrong because all atomic symbols need to start with an uppercase. So I like the SY there.
Yeah, and also you've got this thing linking. See, this is because it's incorrectly tagged. You've got this thing linking to the page for constants.
I'm sorry.
Yeah, I know. It's just that this is what happens if the thing. So I don't actually know how to do this tagging so that becomes an italic string. There's a way to do that. Which I do not now remember. This is some kind of special input. Yeah, you need to find out how to do this, okay?
Okay, so the SY there should be italic.
Yes, I mean,
okay.
I just did it, but I think I did not tag it correctly. Okay? Pretty sure I didn't tag that correctly. And that will cause trouble for the autocompleter and other things, right? Because you don't want it to autocomplete with that. Does Atom correctly autocomplete with elements of the periodic table? I mean, with the things from the periodic table?
No, but that's a good idea.
It should do, right? And you've got to give them a list by abundance, probably, of the different elements.
Yep.
No, not natural abundance, because that'll put something like iron first. I think it should be carbon, hydrogen, things like that are more typically used for this sort of work.
They have way higher abundance than iron.
Are we talking crustal abundance or whole earth abundance?
Well, let's talk crustal abundance. Maybe there's abundance, actually. We also have abundance data in humans. which maybe is 2, right? Which probably will get you, insofar as
it's going to be oxygen and hydrogen for water.
Yes. Okay. Not carbon. Well, okay. So fine. So curate this list.
Yeah. We'll do
Remember
that.
The autocomplete list only depends on first letters. So you only have to know C versus CL and so on.
Yep.
Okay. So I'm not succeeding in making that thing italic. So you need to fix that separately. Okay.
Yeah, we'll do.
What the heck is this? Oh. Okay, but that's not. What the heck is this? No. Look. This table isn't right because this table. No, this table is nonsense, right? This can go in that position, right?
Wait, I don't know what we're saying here. I just meant that you can enter.
I know, but the table is obviously wrong because this here, right? If you're going to do it this way, okay, look. See this? Something like that, right? I don't know what you want to call this, right? Because this says right? Did you get what I'm saying? Because each one of those things can go in that first argument. You get what I'm saying? Any of SY entity, whatever, can go in that first argument there.
So I don't. They can do that, but they can also just put the entity directly in the list.
I'm well aware. That's what this is saying here, right? But the way you had it before, this said that the only thing you put in that first argument was something of the form quotes SY, which is not correct. You get what I'm saying?
Right. Okay. Right.
You understand? Yes. I don't like saying, but what would you call this first thing here?
Well, so what goes in the first argument defines the element.
I know. So do you want to call it element there?
So the problem with element is it has a lot of different meanings, right?
Yes, right. So I'm suggesting it. I'm asking whether there's some different thing that you could have it be.
What about chem element?
Too long. You could say E. It's a little obscure. That's nasty, but okay. Let's go back over here because this page is going to clearly require some work. It'd be really good if you could do the obvious cleaning. No, this is the wrong way round. What you're saying there is the wrong way round. Right? Where the hydrogens. No, that's not whether to include the explicit.
Right. So it's laid out better here.
What do you mean by are explicitly listed in the molecule? That's not what you actually mean. You mean that the molecule is assumed to have them. Not that they're explicitly listed. Explicitly listed would be you actually give atom of H and so on. That's exactly not what you mean.
Well, no. So let's see. So when you create something from a smile string, an H can be implied or it can be literally listed with hard brackets around it.
I'm aware.
And so
yes.
if it's set to automatic and you give it a smile string with explicit H's in it, I will turn them into atom H in the atom
Of
list.
course. Right? So now what? But if it's not explicitly listed, you will add them, but you will not add them explicitly. Is that true? Or will you add them explicitly?
So by default, if you do molecule of a smile string CCC, I will add them because I think.
Yes, but where will you add them? In other words, if I take, let me go back here, okay? So if I have molecule, okay, now I say input form of that. Oh, I see. The atoms are added in there.
Right. I get the impression that a lot of users, so people in the cheminformatics community are going to want them to be not listed there to save memory and everything, but a vast majority of our users will.
Okay, so just explain to me what, okay, so let's look at, if I do molecule here, and we say that include hydrogens. So the default is include hydrogens is automatic. So let's say include hydrogens is none. So now let's say input form of that. Okay, but now let's say, is this really the right way around? Let's say molecule plot 3D, %17. Am I going to see, yes, I'm going to see hydrogens there.
Right.
Because
so
what does include?
Mass, they are in the molecule. They're just not explicitly represented.
So what do you think include really means in this sense? Is it really the right?
Include in the first list.
Or include
No, but include, but in this case.
Structurally include. Semantically,
okay. How does this know that they're going to be hydrogens added to decorate it?
So after some processing, after we've read it in and we've looked at it and we say, no, carbon needs to have 4 bonds to it, and here it only has 2, so we're going to add 2 hydrogens to make it a valid molecule.
Okay, so this thing here does not need to have an include hydrogens option to know to do that. Is that correct?
Right. And in fact, the include hydrogen option is one that evaluates away.
So it's only on the input of the molecule.
Right. It is a constructor option.
I think it's got the wrong name. Well, maybe it doesn't. Let me think about this for a second. Okay, so then the possible, okay, so let's look at include hydrogens here.
So it also does double duty when it's added to some other function where the name seems more appropriate.
I'm sorry, that doesn't make any sense.
So if you do bond list of a molecule, say include hydrogens goes to true or false, it tells you whether or not the thing that is returned has the hydrogen.
I get it. What a mess. Okay, so let's walk through this again. It's got 2 different things it's doing, you're saying. Yeah, this is nonsense. I mean, look, if this says include hydrogens, well,
I think it's not nonsense. I think actually I find it clear.
All right, well, would you like to write what this should say then? It's an option for molecule.
Maybe the word result can be improved.
Another related
I think when it's used in the constructor sense, it should probably be something like generate hydrogens. And when it's used in...
we want to have 2 different options. Hey, listen, practical point. We've got at least 4 more hours of this to do. I am supposed to do another design review in about 15 minutes. We are going to need to schedule this. This week is not exactly spectacular for that. But hopefully there will not be design changes. Let's try at least to get some version of this page. So okay, hold up. There's an option for molecule. Well, that indicates would be that indicates what? Whether
hydrogen should be explicit or implicit.
Yeah, should be whether hydrogen should be explicitly included or not.
I like it because it doesn't have this reference to a result.
Right.
Or the hydrogens.
Maybe let's have atoms to avoid confusion with molecules.
Okay, another functions that specifies whether hydrogen atoms should be explicitly included in results or explicitly included.
I think included because of this double usage as the option, because they are not in the result, so to speak.
And I think you have specified instead of specifies.
Okay, but so let's look at the basic things here. So what is all? All automatic none, or is that what is? And presumably there's a true and false as well that it supports.
Right. I take true and all explicit and all to mean the same thing.
Okay, let's just get a small number of actual options here. Okay. Okay, so the possible values are true.
Isn't this not a table one down?
It's not correct. Let's write it again. Add in hydrogens explicitly. Include or add in hydrogens explicitly. Is that correct?
For the
construct
of molecule, but not for some of the option uses.
Well, no, but it has to be for the option uses, because it is for the option uses. It's when you return an atom list, it's include or add in hydrogens explicitly, right?
Right.
And this presumably should refer to atom list as well, right?
Right.
Okay, so is that?
But say in bond list there is no hydrogen.
So it's included in the computation at that point.
Exactly, but not in the result. That's my point.
Okay. Well, then, okay. Well, that's what this is doing. So true means that, and false means do not treat, I see. Include hydrogens implicitly and do not generate in results. Well, actually, we can simply say do not
Why not just say exclude or delete? Or exclude or remove?
So I don't necessarily feel like we're removing anything with that option, though.
Yeah, I think okay. This is the right thing. I think what we want to say with include hydrogens arrow false. Hydrogens are still included in computations, are still accounted for in computations. Is that correct?
Yes.
But are not explicitly represented or returned. Is that right?
Yes.
I think all this other stuff is irrelevant. What is this? And the unpaired electron count. What the heck is that?
So a person might type in a molecule, atom list O, end atom list, and to a certain user is going to expect that to be just a naked oxygen atom versus water. And so include the hydrogens being explicit or implicit, they're both water.
But please don't use this. What's this doing here? Why isn't that atom list? And why, if you've said M equals, why are you saying first to percent?
Right, that's...
So what happened there?
So atom list will give you the list of atoms for a molecule, not the list of atoms in the expression.
I was just going to say, I think I disagree with this.
So you think that atom list should just return the first?
No. What I'm disagreeing with is the educational point of this example is to look at the structure that was generated, not to get an atom list of the molecule.
Because atom list does some computation.
Exactly, that was my point.
Yeah.
So what are you saying?
So it should be first.
The original one was what we wanted to do. We want to look structurally what had been created.
Yeah. Well,
So
except it does have hydrogens here.
Right, because there are two that are listed in the SMILE stream.
Okay, so in fact, we've got a different case here. We've got true, false, and automatic, right?
Right. And all the
Which
functions
is why
that
we can't say whether or not here. Okay. Include only hydrogens that are explicitly mentioned.
That's why Jason and I had discussed this explicit and implicit.
Well,
so as opposed to true or false.
I don't think it's right. I think if you're calling it include hydrogens, it's either true, false, or automatic. That is, include all necessary hydrogens explicitly, any hydrogens explicitly. Is that right?
Yeah.
Okay, so we're going to have to comment on what it means to include necessary hydrogens.
Right. So I can talk about an atom's valence.
Yeah. I don't know why I keep on typing. I don't know what word I'm auto-completing there too. Okay. Hydrogens are filled in so as to satisfy typical valence conditions for atoms. Is that right?
Yes.
Okay.
So there was a comment from the live stream that I don't know how to give a response, but we do have partial charges as a computer property for the atoms.
Okay. I think you just gave a response. That's
right. I tried to type it, but then it told me I needed a Twitch account or something.
Yeah, that's not useful. Okay. Okay. I think we're going to have to wrap for right now, unfortunately. Do we know when we're continuing this?
So you said this week is busy.
Oh gosh, somebody's just been adding random things to my calendar for today, which I did not approve. That's not going to work.
So I did want to before the let's see. This isn't included in master at the moment. Can we add
what
molecules? The molecule. So it's in a prototype only. Okay.
Yes, we should add it, but there's still quite a bit of work to do on this.
True.
Okay. Look, I don't know when this is going to get done.
So I'll send in a
yeah, maybe tomorrow evening is a possibility. But as I say, I think it's going to take another 4 hours, would be my guess. I mean, I wish it could be less than that. And the more you've cleaned it up, the shorter it will be.
I mean, Jason did not yet so much concentrate on the documentation because we thought we have some time to do this after code release. So now we
the problem is, okay, so listen, we got to get rid of some of the junk like this, for example.
Yep.
And you've got yeah, I'm worried about design changes here.
Exactly, these are the critical things, design changes.
All right, well, to be continued. And for those who are interested, we are going to do another live stream about geo computation in a few minutes. But I will push back these results. I mean, I would love to continue right now, but we can't because we've got to do this other thing. Okay, I'm a little concerned. Gosh, we've gone through most of these quite extensively, although I don't think molecule modify, for example, is something we've gone through in detail. Oh my gosh.
I think we have gone through, but it's one of the functions with the most bells and whistles.
But we spent at least an hour on that already.
Yes, I know we've gone through some of this. Have you guys gone through? Yeah, I mean, right. Okay, I got to wrap up here. I will see you guys in due course. And for folks on the live stream, I encourage you to drop in on our geocomputation discussion, which is starting in just a few minutes.
Okay.
All right, see you later.
Thanks.
Bye.
Bye.